This is kind of this lesson right here is kind of a man, it sounds very loud. Let me turn that down a little bit. It's kind of continuation of what we've done before. We learned how to prove triangles congruent. Do you remember? Let's do this. Let's put ways to prove triangles congruent. So far, we've only learned 2 ways. We're going to learn 2 more today. All right? Do you remember the first way that we learned to prove that 2 triangles were congruent to each other? Besides showing all 6 parts, and besides showing all 3 sides and all 3 angles. Sydney, what was the first way? No. We had 2 ways. Side, side, side. I heard that. Okay? Side, side, side is one. And what was the second one? Side, angle, side. So what did side, side, side mean? It means if you had 2 triangles next to each other, right? And I could show that 3 sides of one triangle equals 3 sides of another triangle, then that means those triangles are congruent. I didn't have to say anything about the angles at all, did I? Okay, just showed 3 equals 3. That's side, side, side. What did this one say? This one said if I can show 2 sides of one triangle and a what? What did I call that angle right there? Not the in-between angle. I gave it a name. The included angle, all right? The included angle. What does that mean? It means the angle that's between those 2 sides. For instance, if I had a triangle right here, say we'll just do like this. Okay, and if I said I've got this side equal to this side, that's one set of angles, right? So that's one of my sides. And I've got a second side right here. That's my other side. But what about that angle? Can that angle be right here and here? Is that enough to show that my triangles are congruent? No, it's not. Okay, because something has to be true about that particular angle. It has to be the included angle. The included angle means the one that's between the 2 sides. So which one? Is it the top one, the bottom left one, or the bottom right one? It's the top one. The top one is the one that's the included angle. It's the one that's between those 2 sides. Do you see that? So if I could show that this and this side are equal, the included angle is equal, and the other 2 sides are equal to each other, if I could show that, that's enough to say that those 2 triangles are congruent to each other. Everybody with me on that? All right. And I know you have a homework that we need to go over, and we will go over that as soon as I finish this lesson up. So we should have time to finish. So we'll do a little bit more with that. So really, this lesson and the lesson before is kind of the same thing, except we're going to learn 2 different ways to prove the triangle is congruent. And let's drop this down. So here's the third way. The third way is called angle, side, angle. And let's put these triangles here again. So you should have a general idea of what we need to find here. And let's label it. ASA? Oh, right there. Yeah, I have my dad's. I think my dad has an uncle named Asa because he always talked about Uncle Asa all the time. So, yeah. All right, so here we go. Now, what do you think is going to be given here? This time, if I can show that 2 angles of this triangle and 2 angles of this triangle, and what? Not just any old side, but the what? The included side, right? The side is between those 2 angles. So let's say they told you that angle A was equal to angle D. And for some reason you knew, or they told you that angle B was equal to angle E. All right. Now that right there is not enough to say those triangles are congruent. All right. But if they told me that this side right here was equal to this side right here, what's true about this side and those angles? It's the what? It's the, what's this true about this side? It's the, we just said it 2 seconds ago. It's the included side, isn't it? Okay, it's the included side. It's in between those 2 angles. If I can show that, everybody with me? If I can show that this side is between those 2 and this side is between those 2 equal angles, then those triangles are what? Are congruent. Okay? Nope. We'll talk about that, though. Let me see what I'm going to say about this. Okay, so now I could say this. Let's just write it down. I could say that, let's put the triangle symbol. Triangle ABC is congruent to, now watch, if I go ABC, what am I going to have to go over here? DEF, okay? Got to make sure that they match up. It's very important that you do that. Everybody with me on that? Now look, I don't know anything about AC and DF. I didn't know anything, before. Right? I don't know anything about BC and EF. I don't know anything about this angle and angle C and angle F. But now, once I've proven these triangles congruent to each other, and this is very important. I need you to pay attention. I need you to really focus in right here. Okay, this is really important. If I'm able to show that those two triangles are congruent to each other, and I have, and what's my reason? Why? Why are they congruent to each other? Because of angle side angle, right? So there is and this is a postulate, by the way. Do you remember the difference between a postulate and a theorem? That's the other way around. A postulate cannot be proven. It's just an accepted fact, okay? You just accept it as fact. Now, a theorem, you can prove a theorem, right? A postulate, this is an example of a postulate. It just can't. It just is accepted. You just accept that this is true. If I have two triangles, and if I show that two angles and an included side of one triangle equals two angles of an included side of another triangle, then they're congruent. We just accept it. Okay, just believe it. All right. Most of the time in geometry, you're like, oh, prove it to me. Prove it. Prove it. We do that all the time in geometry. In this case, on a postulate, we just accept it as a fact. All right. Remember the toothpick thing? We talked about this earlier. If I gave you some toothpicks, right, and I made sure that this was, I don't know, 5 and this was 5. You with me on this? And I said, okay, you've got two other toothpicks. I don't know how long the other toothpicks are. Okay, but this toothpick over here has to make a certain angle, the same angle as this one. And this toothpick right here has got to make the same angle, and they have to both come to a point. You're going to find out that those two toothpicks have to be exactly the same. So that means that that has to equal that, and this one has to equal that. I'm not going to go through and try to show you why. Just believe it. Just believe it, okay, that this is true. That's correct. Right. And so there is a theorem that says, and it's called the third angle theorem, that says if two angles of one triangle equals two angles of another triangle, then what must be true about the third angle? The third angle has got to be equal as well. But we didn't even really have to know that, because we already knew that these triangles were congruent because of angle side angle. So what must be true about the other parts to it? They must be congruent too. So since the triangles are congruent, what can we say after that? We can now say that AC is equal to what? DF. We could also say that BC is equal to what? EF. And we can also say that angle C is equal to angle F. Question is, why? Why? We did this before. Remember, we've shown the triangles congruent to each other, right? AC and DF line up with each other. They are what kind of parts? Come on, it's a word we used a couple days. Corresponding, very good. They're corresponding parts, okay? Because if I took this triangle, picked it up, and stuck it right on top of this triangle, they would match up with each other, wouldn't they? All right, so AC and DF are corresponding parts. They're corresponding parts of congruent triangles, aren't they? The triangles are congruent because of angle side angle. So what's true about all the parts that match up with each other now that I've shown the triangle's congruent? They've got to be what? They got to be equal. They got to be congruent. And what's our reason for that? No, it's not ASA. Angle side angle is the reason why the triangles are congruent to begin with. Why is AC equal to DF? And why is BC equal to EF? And why is angle C equal to angle F? Because they're corresponding. They're corresponding what? Parts of what? Congruent triangles. That makes them what? Congruent. Okay? Remember that? Let's get this straight. I know at first it's hard to understand, but we've actually talked about this, I think, about 2 days now. All right? So it should begin to start sinking in right now. I know you don't have complete understanding of it, and it's going to take a while. This is something that takes a little bit of time. But, we should at least recognize this. Do you at least recognize it from talking about it before? Yeah. Again, what does it mean? Okay, what is the significance? The significance is once I've shown two triangles congruent to each other, right? See the stuff in yellow? That's why I put it in different colors. We knew that the yellow angles were equal and the yellow sides were equal. I didn't know anything about the other stuff, did I? But if I know the yellow stuff is equal, now I know the triangles are congruent to each other, which means they're exactly the same. So if they're exactly the same, what must be true about the other sides and angles that I didn't know anything about before? They got to be equal too, right? And that's what this thing is saying. It's saying, okay, if my triangles are now congruent, all the other stuff, all the other parts of the triangle that I didn't know was equal before, they've got to be equal now because the triangles are congruent and they match up perfectly. They match up right on top of each other. Yeah, that's right, because what is it? It's the corresponding what? Parts, right? This is showing me that the corresponding parts, the angles and the sides, okay, the leftover angles and sides, if you want to think of it that way, okay, that thing CPCTC tells, okay, all the other stuff, all the other parts must be equal to because the triangles are exactly the same. Does that make any sense at all? So I know the triangles are congruent. Why are the triangles congruent? Angle, side, angle. And that's all I know right now, isn't it? Okay, that's all they told me. Remember, they told me that yellow stuff right there. Okay, the book told me that those angles were equal and the two sides are equal. Since I know that stuff right there, now I know that angle, side, angle, side, angle. Now I know my triangles are congruent. They didn't tell me anything about AC and DF before, did they? Did the book tell you that AC and DF were equal? No. Did they tell you that BC and EF were equal? No. Did they tell you that angle C and angle F were equal? No. They didn't tell me that. But with the information they told me, I was able to figure out the two triangles were congruent to each other. Once the triangles are congruent to each other, that must mean all the other stuff must be equal to each other as well. That's what CPCTC is telling you. Okay, that the corresponding parts, the parts are the angles and sides of congruent triangles. Do I know my triangles are congruent? Yes, I do, because of angle, side, angle. That must mean those corresponding parts, AC and DF, BC and EF, angle C and angle F, those corresponding parts now have to be what? What's that C right there stand for? Congruent. Okay? So let's say it again. What does the C, what does the first C stand for? Corresponding what? Parts of congruent triangles are congruent. Okay? Everybody see that? All right, let's do another one. That was a postulate. This next one is, and I'll just use the same triangles. Let me just copy these. The next one is a theorem, which is really not much different as far as what the look of it is. And, oops. That's all right. I did put this up a little higher, but I don't know, P, Q, R, and let's call this X, Y, Z. All right, what if we had this? What if I said that this angle is equal to this angle, and this angle is equal to this angle? All right? So it's kind of starting off the same way as the other one did, right? They give you two angles of one triangle equaling two angles of another triangle. But watch, they don't tell you that PQ and XY are equal to each other. If they did, that means they'd be congruent because of angle, side, angle. But they tell you this. They tell you that QR is equal to YZ. Can I use angle, side, angle on this one? Can I use angle, side, angle? Don't write this down. Don't write that down. That's a question mark. Can I use angle, side, angle? Why not? Because what happens to be true about that side right there? Is it the included side? No. So you only use this when the side is what? What did I just say? Included. Okay, is it included? Is it between the two angles like it's written here? No. So this is not angle, side, angle, is it? Okay, we have another one though. And this is called, what do you think? Angle, angle, what? Side. That's right. And you're like, well, what's the difference? I mean, so what? You got two angles and you got one side. What's the big deal? Well, on this one, the side is not included, is it? You see it? And it's not in between. And it shows you right here. You got two angles next to each other and a side that's not in between those two angles. means it's in between. Included means it's in between. Is this in between these two angles? Which one would be in between these two angles? Which side would be in between these two angles? PQ, right? But it's not, is it? This is QR. So this is why we call it angle, angle, side. This is a non-included angle. I could have also, what's another way? What's something else that I could have known to still use angle, angle, side, Jack? You could do this one, couldn't you? Is that still angle, angle, side? Yeah, it is. Okay, two angles and a non-included side. That would still be angle, angle, side. As long as it's not in between. If it's in between, you use this one. Okay? If it's not in between, you use this one. Make sense? All right, I'm going to throw something out here that maybe some of you will catch, but some of you won't. It's not that huge of a deal. But watch this. Connor, remember you said if two angles of one triangle equal to two angles of another, then what must be true? Then the third must be equal. So angle R and angle Z must be equal to each other because these two are equal to these two. Agree? Now look what we have, though. Now we have what? Angle, side, angle. So really, it's almost like there's no use for angle, angle, side, because we could have always said, oh, this angle is equal to this angle. But what this does, this saves us a step. This saves us a step from saying that angle R is equal to angle Z. Does that make sense? All right, so we could just go straight to angle, angle, side instead of saying, okay, if these two angles are equal, then this one, now it's angle, side, angle. All right? Some of you might have caught that. Some of you might not have caught that. It's not that big of a deal, but it's kind of interesting to see. But we do have two more ways to prove triangles congruent. So what are the four ways? Let's list them. And you might want to list them in your notes, okay? It's nice to have them all down. What was the very first one we talked about? We even reviewed today. Side, side, side. We say side, 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 okay? So don't say verbally SSS. We say side, side, side. What's the next one? Side, angle, side, all right? So those give you at least two sides. What about three? What's the one we learned today? What's the first one we learned today? Right, this time we had two angles and an included side. And then what's the fourth one? Angle, angle, side. So now we have four ways. Listen. We have four ways to prove triangles congruent to each other. Okay, and those are the four ways. And write that down. 4 ways. All right? Blah, blah, blah. You fill in the blah, blah, blah. 4 ways to prove triangles congruent. Okay, and those are your 4 ways. So if they give you a proof and they say prove that triangle ABC is congruent to triangle XYZ. If they tell you to prove that, you only have 4 options. What are your 4 options?
Side, side, side.
Right, it's these 4 right here. Exactly right. Side, 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 angle, side, angle, and angle, angle, side. Those are your 4 ways. So if I asked you, why is this triangle congruent to this triangle, you only have 4 possibilities. Are you hearing me on this? This is very important because you know what some of you are going to do? Some of you are going to write a reason why these triangles are congruent. You're going to write CPCTC. But that doesn't make any sense. If you know what it means, you'll look at it and you're like, wait a minute, I can't write that to prove triangles congruent. That doesn't prove triangles congruent. That proves corresponding parts of congruent triangles to be congruent. You follow me? So your only ways that you can prove these 2 triangles congruent to each other is one of these. And it all depends on whatever they give you and whatever you can figure out. All right? Because I'll show you why. Look. No, you don't. Because look. Look what I did. I hit the shift key, which keeps it in proportion. We have a whole chapter where we talk about triangles that are in proportion and similar triangles and all this stuff, okay? I'm not going to get into that too much right now. But look, this angle is still exactly the same as this angle. If you don't believe me, watch. Look at that. It's exactly the same, isn't it? Okay, so that's one angle equal to another angle. Look at this one up top here. That's exactly the same. Look at this one down here. That's exactly the same. Would you agree that all 3 angles here are equal to the 3 angles here? But are the triangles even close to congruent to each other? No, they're not. Okay? The angles change the shape of it, but they don't determine the size of it. All right, so there is no angle theorem, okay, for congruent triangles. Now there is one for similar triangles, but that's another chapter. Okay, it's like in chapter 7, I think. No, all the triangles you're going to have are actually congruent to each other. Okay, it just depends on what they give you. All right, what if they give you this? Let's do a quick little. Now, just watch. What if they give you that information? Are those triangles congruent to each other?
Yes.
Why? Give me one reason. I gave you 4 reasons. Look, I gave you 4 ways. You're not going to give me a long, drawn-out explanation. What are you going to say? Side, side, side. That's all you're going to say. Okay? You don't have to explain it. All you got to do is say what? Side, side, side. Okay? Let's get rid of all that. Okay? What if they give you this? And this. Are those triangles congruent to each other? Yes, they are. Why are they congruent? Side angle side. You with me on that? Okay. What if they did this? The triangles are congruent because of side angle side. But what if I asked you to prove that this angle was equal to this angle? That's right. These 2 angles would be equal to each other. Why? Because we just proved the triangle's congruent, didn't we? This angle would equal this angle because of corresponding parts of congruent triangles are congruent. CPCTC. You see the difference? Okay, you only use side angle side, side side side, all that kind of stuff to prove the triangles exactly the same. Once you've proven the triangles congruent to each other, then you can say that this angle is equal to this angle because of corresponding parts, CPCTC. Or you could say what else? You could say that this side is equal to this side because they are what? Corresponding parts. Jack? No, there's not. And I'll show you some other day. I actually have a little video, if I can find it. Now watch. It's a good question. Does side-side angle work? Right? Now, if we wrote it the other way, which I'm not going to do, all right? But if we wrote it the other way, it writes a word we probably shouldn't say, right? Now, that's not the reason why it doesn't work, okay? But it's a silly way that you can remember that, you know what? I don't think there's an angle side-side, all right? Because if I wrote that down, it'd probably be something I shouldn't be writing. So if you want to think of it that way. But there actually is a reason for that. I have a video. Maybe I'll show it tomorrow. I'll find it. It's on YouTube. It's not one that I made. Somebody else made it. It's a really, really nice explanation of why that doesn't work. So that does not work. Not because of what it writes out. All right? It just doesn't work. So if I gave you 2 toothpicks, right? One's, one length and another length, and I gave you an angle that's not, listen, and I said, okay, make a triangle, but you both have to have the same angle, but that angle is not the included angle. It's some off angle, right? 2 sides and an angle here and an angle here. You guys could actually make 2 different, distinct triangles, and they won't necessarily be the same exact triangle, all right? That's not a very good explanation. I'll explain it some other time, all right? Maybe tomorrow, all right? Let's do this. Let's get rid of all this. Oops, I went too far. Now, how do I get back to that one? Nah, I was undoing to get rid of it. It'll just go back. There's a yeah, there is. There's like a shift or alt.
Control, Alt, Delete, Enter.
It's Control Z for undo, but it might be Control. No, it's Alt Z. No, Control Z. No. Anyway, that's all right. Who cares? Enough of that. Let's see. I think that's good enough, to tell you the truth. We'll do some more. I'll do a little bit more tomorrow. If you look on page 276, they give you a nice little chart right there, and they go through all 4 ways. It's a chart, okay, and they show you all 4 ways to prove triangles congruent. They draw the pictures right there. They tell you up above angle, side angle, and all that good stuff. Okay, that's really, really a good thing to do. Tell you what, let's do one. We got a few minutes here. So let's actually do a proof. Now remember, these are modified proofs. These are not real detailed proofs. Yeah, write this down, absolutely. Whatever I write down here, you should write it down. I'm going to make this look a little different. Let's go about like that. Alright, why didn't it do it? Alright, why didn't it do that? Oh, because I hit scale. That was dumb. Let's try this again. Sorry. I want to hit shear. That's what I want to hit. Yeah, that's better. Okay. And I'm going to put a line in here. Now watch very carefully. Everybody looking up here. This is ABDC. So this is A, B, D, and C. Alright, look what they do. They tell you some given stuff. They give you, now this is very important, now watch, that CB bisects. I don't have everybody's attention. Why not? I've asked you very politely a couple times, and I still have people that are not looking up here. Thank you. Write this down. What does it mean to bisect something? Two equal parts. It divides it into two equal parts. We've talked about that word before. And I'm going to show you all you have to do. There's really not much to do, to tell you the truth. But you have to do what I ask you to do correctly. All right? I'm not asking you to do a whole lot. This is a lot less than what I would ask the honors class to do. All right? But it's still the same idea. You still have the same basic principles involved. They just have to write out a whole bunch of stuff, okay? A lot of detailed stuff. All we're going to have to do is just mark the picture and then tell me why these triangles are congruent. That's it. So let's see what they tell you first. It says CB bisects angle ABD. Well, what is CB? CB is this one, right? It bisects angle ABD. Where's ABD? That's this big top right angle, this big angle B right here. Everybody see that? It says it bisects it. What does that mean to bisect something? It doesn't just go through. It goes through and it splits it into two equal parts. Okay? So that means that that angle is equal to that angle. That's what that means right there. When it says CB bisects angle ABD, it means it splits that angle into two equal angles. Everybody with me so far? But it also bisects what else? ACD. ACD. So what does that mean? It means that these two angles right here are also congruent to each other because it bisects that big angle C. So that angle split in half and this angle split in half. That's all they tell you. Is that enough right there to say that this triangle is congruent to this triangle? It's not. But we've discussed this earlier. There is something that you can just look at the picture. There's something that you can just look at the picture and you can tell by looking at the picture. Look, I've got a triangle here and a triangle here. Jack, what do you think? For what reason? Say it, Connor. No. Reflexive property. But you don't need to write that, okay? The honors class would have to write down all the reasons. You guys don't have to do that, but watch. So just put one little tick mark right there. You see that? CB in this triangle is the same exact side as CB is in this triangle. So it's equal to itself, isn't it? It's called reflexive property. Now look, is that enough information to prove that this triangle is congruent to this triangle? Let's give somebody a chance. What do you think? I've got an angle, I've got a side, and I have an angle, don't I? The side is included, isn't it? So what's my reason why the triangles are congruent? Angle, side, angle. That's all I'm asking you to do. Okay? Everything in yellow right there is what I'm asking you to do. Now, on your homeworks, though, listen. On your homeworks, I want you to write the picture. I want you to label it. I want you to write the given. I want you to write the prove. So everything I've written right there is what I want you to do. Okay? I'm not even giving you homework tonight. I'm going to go over a couple more of these tomorrow. And then I'm going to let you start working on the problems in class tomorrow.